Hi, Assalamualaikum. My name is Isham Sahar bin Ismail. I'm from Polymas. My research paper is Configuration Walking Parameter for Darwin OP in Hero Cup Weightlifting Competition Viral Malaysia Cup for ICIRSST 2020. Introduction. In Darwin OP, hominid robots walking process walking parameter has a significant influence in the weightlifting competition. To achieve a balanced walking with load in weightlifting competition, it is necessary to study the initialization dynamic stability of the robot. So, in this paper, we propose a feasible method to overcome the walking instability of Darwin OP hominid in weightlifting competition by programming in code light get the effect of parameters such as hip, pitch, offset, z offset, etc. Problem statement. Darwin OP movement has a tendency to move to the left and eventually out of the line before crossing the finishing line. The second one is Darwin OP could not maintain walking to the finishing line while holding the barbell without falling. Objective: to find the final setting to 1. Reduce and minimize the robot tendency to walk out of the line before reaching the finishing line. Second, Darwin OP could maintain walking to the finishing line while holding the barbell without falling. Scope. First, walking tuner. Adjust the setting in walking tuner that reduce walking error. The second one is hard coding. Hard coding using code light. The parameter value Z offset, hip pitch, foot height, double stand period, DSR ratio. Literature review. Kajita proposed to use three-dimensional linear inverted pendulum that allow to simplify a walking pattern generation. In the paper, they assume support leg exchange is in constant pace. So by modify the foot placement, the walking speed and direction of the robot will change. Second literature review, Gregory-Vasiliev present biped robot balance method which are used in their research and force sensitive resistor FSR implementation. To observe the walking controller method, they use Robotis OP3 robot. The center of pressure for the foot was calculated according to relative distance average location of the individual FSR sensor on the foot. In this paper, they add a sensor, they place it on foot, they use it to estimate the robot movement. Okay, methodology, flowchart of walking tuner parameter tuning. First, start, and then commencing walking tuner. We go into the walking tuner setting to set the parameter. Okay, change the parameter needed and run the robot. Okay, if the robot walks straight or it did not fall, so we save and exit the walking tuner. But if the robot is walking not straight, or the robot is fall down, then we need to change the parameter until the robot walking straight again. Okay, after save and exit walking tuner, the process will end. There are four phases that we need to change according to the disc or according to the weight that the robot will carry. The first one is first phase or no disc. This phase will start with a combination of A where the parameters are stated in table 1. The robot were not moving while using combination A. In combination B, parameter that had been changed was Z offset parameter, and the finding was the robot start to move but fell backward. In combination C, finding was the robot were now stable to move. In combination D, it is increased the phase. Adjust was made in period time parameter. By using this combination, the robot pace was increased, but it cannot maintain instability and move to the left. So the foot height parameter will adjust in combination E to make sure the robot will not fall down anymore. As a result, combination E was the default tuning or initial tune for the robot for weightlifting working parameter of the robot. Okay, the second phase is 10 this compact this as a weight. During this phase, by using the default tuning from the previous one, from the phase 1, the robot fell down immediately when the program started. Okay, to overcome this, the problem, value of hip pitch was reduced to 0 in combination B, but now the robot fell down backward. The hip pitch will adjust one more time to 4 in combination C, and finally it moved smoothly without falling. Okay, for 10 Ds of phase, second phase. Okay, in third phase, 20 compact Ds, the weight increased to 20. In third phase, by using the result combination in phase 2, the robot moved but somehow it fell down backward before reaching finish line. To overcome this problem, value of hip pitch has been raised slightly in combination B, but it now fell forward or it fell in front before the finishing line. In combination C, adjusts were made to make the hip pitch. As a result, the robot will move stable and it reached the finish line. This one is for combination or for third phase, 20 D. The fourth phase or the final phase. During this phase, the robot fell down immediately by using combination C parameter from previous phase. Firstly, in combination B, head pitch offset value will adjust, but the robot fell forward after few steps. To overcome this, the robot head pitch offset, double stand period, the SP ratio high were reduced by reducing Z offset in combination C. The robot now managed to move further but out of the line before reaching finishing line. The robot pace were being The robot pace have been identified as the problem for combination C. Therefore, double stand period, the SP ratio parameter have increased in combination D. As a result, we managed to get a smooth robot movement and reach the finishing line with 30 Ds. After finishing the fourth phase, discussion that we made from the result that were obtained, hip pitch play an important role in the movement of the robot, but this does not mean that other parameters are not as important. From observation made, if the Z offset can be reduced, then the robot height will be low at the same time lowering the center of gravity of the robot, thus enabling the robot to be in a more stable while walking. In addition, changes in hip pitch parameter can stabilize robot body when the load is lifted. This can be explained when the load is increased, robot hip will be more rearward to the compensate for the weight of the load. Finally, the faster the robot move, the less stability robot get. This is due to factors that are affected by the load initial forces. Conclusion. As conclusion, by understanding which parameter to be adjusted, robot tendency to walk out of the line before reaching the finishing line can be minimized and could maintain walking to the finish line while holding the barbell without falling. This is my reference. Okay, that's all. Thank you.